Okay, alright, so I think we're almost done here. So we have the pixel x in terms of the pixel x and the pixel y in terms of a 256 by 256 region. And we've already done the math here for figuring out where the these origins are, right? So in our diagram, um, the CMX, CMY are these origins here. These little origins with the at symbols right here. These are the CMX, CMY origins. And with that, that's going to be able to take this a 256 value, a value that's somewhere mapped somewhere into here, and we can map it into the 512 by 512. And once we have it mapped into the 512 by 512 with the xy, then we can convert that xy into an index. So CMX, CMY, multiply by 256. So I'm pretty sure that all we need is I32, PX 512 equals CMX plus PX 512. Okay. And then I32PY 512 equals CMY plus PY 512. Okay. So X's, and that's not quite right because I'm not thinking here. This is a 256, right? Is the 256 variables from further up here, right? 256. Okay, so now that we have that, we should be almost out of here. Like, let's make sure that we know how we got this index converted to an xy, and make sure that the xy's make sense. So it looks to me that when we take the index 512, we do to get px 512, py 512. It's just a normal index to xy calculation there, so that shouldn't be a problem. Okay, yeah, so if that's the case, and actually we can, yeah, it's just a normal index to xy calculation, so if we just inverse that, then we'll be good to go. Okay, so over here, if we want VI VI 512, and this pixel x, there is no pixel z because we're mapping onto the 2 dimensions here. VI 512 should equal PY 512 times 512, and then plus whatever is left over, PX 512. Okay. So PY 512, we multiply that by 512, so we multiply by the width, and then we add whatever is left over, and that should give us the VI 512 value. And then we're good. We're, like, done. We've done all the math. And it's... So I feel like this is really convoluted, where it's like, holy crap, that's like a lot of... This is a lot of stuff just to... that's a lot of stuff to just get an X and a Y location on, like, a buffer, right? That's like... How's it going? Yeah, that's a lot of stuff for just getting an X and Y, but you know what? That's what we have. So I mean, that's what we got to work with. So let's go to www.tinyurl.com/sdf-019 demo. We're gonna go open up the. That is still okay. Oh, it's still loading because I'm like, why is this YouTube? Apparently well, I have internet, so I don't know what the heck is going on there. Okay, cool. So now, is this not? Well, that's disconcerting, isn't it? Do we have errors in this code? Do we like leave it in a bad state for some reason? Because that would be pretty stupid, wouldn't it? Oh yeah, we have this error called finish this, right? We wanted to make sure that we would finish the common code, and so I put like an error in there to make absolutely sure I would finish it. I don't know if I should do that. It's bad to leave code in a broken state. Not that we kind of completely left it in a broken state. We were coming back to it, right? But okay, let's see what kind of mistake we made here. Oh yeah, that's just a habit of mine that I'm not allowed to have when it comes to this code. So over here, this little in this section, that double semicolon thing I do, not allowed in this code. So let's just fix that up, and let's hope that we were careful enough not to make any. Oh my, we were careful enough. Okay, so no other mistakes, huh? And we can still do that. Okay, cool. So the next part is getting a kind of like a grid rendering, right? And yeah, let's open up the image code. Okay, so in our image code, right, nothing complicated. We're just fetching texels from the buffer, and we're not really interpreting those values as tiles. But let's take those fragment chords, figure out what tile we're in. As far as the layer, we'll just hard code the layer for now. We're gonna hard code the layer, and we'll figure out those details as we go. But let's just hard code a layer index. So hard, I don't know, define temp, I don't know, let's just do I32 I don't know. Do something like that. That's 7 characters, right? Yeah. 1, 2, 3, 2, 3. Not quite 7. Okay, we could call it lattice64 equals 0. Active Z layer index of voxel map. So something like that. I don't know. We call it zdex64. I don't know. Or we could do it dex z64. I don't know. Well, if it's just z64, why don't we just call it z64, right? Let's just keep it as Z64. Let's not worry too much about the names here. Let's just add it here. Active layer of voxel map in 2D view, right? And we'll just give it a definition, and we'll just move on, right? Because if we try to think too much about that, it's just going to give us headaches. So let's keep on moving. Okay, so Z64, and we want to divide everything. We want to figure out what cell we're in on the X and Y, and we're just going to divide everything. So I32 cell 64 cell 64x equals the fragment chord divided by the size of a tile will be I resolution dot x divided by 64, right? So I'm going to take the fragment chord, and we're going to divide by the size of a tile. And the size of the tile is just going to be 1/64 of whatever the I resolution is, right? And then we need to do a int I32 and a trunk, right? So we truncate it. And there we go. So I32 C6Y and I32 trunk fragment chord divided by I resolution dot Y divided by 64.0. Okay. And we'll make a note of what C64 and C what these variables are. So cell 64 X X voxel cell in 2D cross section view. Okay, C6Y is going to be cell 64Y Y voxel cell in 2D cross section view, right? Okay, so we have those. Let's go back to it, right? So I've added the definitions for these variables. For these variables here. And now we don't want to just blindly do color 4D. We want to do some type of fetch where we do well, technically this is just voxel X, voxel Y, right? Yeah, that's exactly what that is. So what we're gonna do is we're gonna say so we're gonna go over here into our avoid, use, so all this is VZ. Voxel Z, right? Over here, because I'm thinking that we came up with these extra names, but let's not use them because C6X is just voxel Y, right? Now that I'm thinking about the math there. And then this is V. Oh wait, hold on. Did I screw that up? Voxel Y. Over here, this is VX, right? So XY, ZXY, ZX, and Y. So yeah, we don't need to use these unless they have a different name. Then we don't want to fractionate our namespace. We don't want to fractionate the names we're using. So if we already have a name that makes sense for this, we want to just keep on. We want to keep on doing that. And also, let me look at my ASCII diagram thing for a second. And let's if I have. Okay, if this is the center, let me adjust this so now that I'm thinking of it, even though it's nice to know what files I have open, when I'm doing full screen, it kind of would make sense to I have a little arrow on my monitor showing me where the center is, so if I keep everything by that arrow, it's going to make it a little bit easier for me to know that I'm focusing on the screen. So I'm going to keep that there like that for now. Okay, so yeah, so we want to add these to our list of names to avoid, just because we already know what they are. And also, what the hell is that supposed to? Sure, why not? But yeah, we just want to add these to our list of things to avoid because we don't want to fractionate our namespace. We already have variables that mean that, so let's use them rather than accidentally using more variables than we need. So this is just VZ with the Z layer, and this is just VX, and this is just VY, right? We're just getting a two-dimensional view of what is going on, right? And then we can pack that all into a IVEC4 or IVEC3 called V3D for voxel 3D, and that equals IVEC3, and it's just VX, VY, and VZ. And then to get the U32 voxel byte, we're going to do V3D, and we're going to convert it to a we're going to take V3D, and we also need the sampler. We need V3D and the sampler, and we're going to convert that into a voxel byte, right? And V3D. So if I got that correct, if I've been consistent enough with my naming, then even though I don't remember what that is, that should be what it is, right? So if we go into our common code, and we're going to hope that this is what it is, and yep, so we see V3D, we see the exact function name right here, V3D SAM C2 VOB, right? So we're going to take the voxel 3D and the sampler, and we're going to convert it to the voxel byte value, right? So going back to our image code, we know that when we're calling this, the parameters are V3D and SAM. So we need to do V3D, then we need to do SAM, right? And what is SAM? So SAM is the SAM is the sampler. So it's like sampler 2D. I don't even know if we can do that. I think we can have to just do a define. Define SAM. I don't think we can assign it. It's like a iChannel. iChannel 0 is like a define, so we can't assign it to something, from what I understand. So we'll do define SAM, and we'll do I channel 0. And then over here, we'll just undef it. Undef Sam, right? And that way we can still kind of keep that naming convention, but that's just because of how things work. And then once we have that voxel byte, we can convert it to a color 4D value, right? So we could do something like, we could do a voxel byte C2 color 4D. And so voxel byte to color 4D, right? And yeah, let's just do that. And we'll take the voxel byte and put it in there, right? And then in our common code, let's go back to our common code. And this is tile layout code. Tile value mapping code, right? So make another section. And tile value mapping code, right? So we're trying to be a little bit more sparse with how we section this off than we were in the last time we wrote this stuff. And this is going to be a color 4D is always a float. So C4D means, do we have a definition already? We should, yeah. 4 dimensions, right? So we're going to do vec4 and U32 VOB. And then we could just do okay, and we can put the return value right there, and then we can do C4D.x equals the voxel byte, and the voxel byte only has so many bits in it, right? It has 8 bits, so we could use like 2-bit color. Well, actually, no, we don't need let's not worry about alpha. So, well, that doesn't divide evenly. But yeah, let's try to use 3, 6, 9. Nope. So we got to use 2 bits, huh? And how are we going to create a bit mask for that? Well, okay, yeah, so let's just take the voxel byte. Let's take the first 2 bits. And U32, 2. This is already U32. And then we're going to AND it with 0x and... actually, we're going to AND it with a U32, and it's just going to be so I believe... No, that's not quite right, is it? No, that's a bit mask. We want we really just want 0, 1, 2, 3. We want to shift it over with a... Let's just make a define here, so to make this a little bit clearer. Define bin 1, 1, and it's a U32, and it's 3, right? Because 0, 1, 2, 3. Yeah, so that's 3 set bits. And then that's going to make the mask a little bit clearer if we mask it like that, right? And bin 111, right? Then we can do the same thing with X, Y, and Z. X, Y, and Z. But shift it over 2, and also this is not 2. So X, Y, Z, RGBA. We're going to use the first 2 bits as red, the second 2 bits as green, and the next 2 bits after that as, well, hold on, RGBA, RGB, no, so we should actually do blue, so actually, other way around, 4, 2, and 0. We want to just keep it consistent with how it would be done in RGB packing, so RGB dot B, right? So RGB dot G, and then RGB dot R, right? And we just want to do it in that way because of the order, right? It's this is 1, 2, 3, right? We want to do it in that order: R, G, then B, R, and then R, G, then B. We want to keep that consistent, like packing order, and well, hold on. X, Y, Z, red, green, and blue. No, well, hold on. So when we do... No, we don't. Red, green, and blue. So red, green, and blue. We want this here, and then red, green, and blue, right? Red, green, and blue definitely correspond to X, Y, and Z. No question about that. And are we shifting this right? The red is all the way over to the extreme left, the green is in the middle, and the blue is on the end. Is that what we're doing here? Okay, yeah. Okay, now we have it. We just can't seem to make up our mind here. So then we'll just undef the bin 1, 1, and then right down here we'll just return C4D. Okay. And that should be all we need to do. Let's update some of our code. So we updated the common and the image. So let's take the common code and let's paste it into common and make sure we didn't make any mistakes there. And we screwed something up. So let's go check out what we screwed up and assign uint to float. Oh yeah, so I'm just being stupid again. So once we get that value out, we need to convert it into floating point, right? So this is, you know, this is a U32 R, G, and B, right? R, G, and B. And then over here, C4D dot X equals, we're going to convert the red to a float 32, and then we will divide by 255.0, right? And then we'll do the same thing for everything else. For the X, Y, and Z is R, G, and B, respectively. X, Y, Z. Okay. So Z. Okay, so now that would be the correct math, because I seem to not know what I'm doing. Also, but there is actually more I need to do here. So we only have 2 bits, right? So 2 bits would be 3, correct? So we need to multiply the R by something to give like a little bit of a range here for the value. So if we have only 2 bits, then we have 0, we have 1, and then we have 2, and then we got 3, right? 0, 1, 0, 1, 2, and 3. So we're basically going to have black, full intensity, and then like 2 middle shades, which, you know, I don't know, whatever. So let's say we have like 255, and we divide that by 3 to figure out like what our step size is, and we get like 85. Really? It goes in evenly? Really? 85 times 3. It does go in evenly. Okay, yeah. Alright, so we'll take, technically it doesn't matter, as long as, if we're dividing and multiplying, it shouldn't matter what order we're doing it in. But let's do this times F32 to 85.0, and then, so, you know, upscale our 2 bits in range 0 to 3 to range 0 to 255. 0 to 255, right? That's what we're doing. By 85. Okay. That's all we're doing, and then we can divide by 255 to normalize 0 to 1. Okay. So that should be correct now, but you never know. I definitely am good at screwing things up. So let's try that and see if we have any mistakes in the... looks like we have some type of mistake. Let's see where it is. Uint, syntax error. So uint is one of my defines. So in our bin, we did U32 3. It's right in the... Why is it right in the middle, though? That's interesting. Yeah, I'm not sure what that is about. I don't know. Let's wrap that around. Oh, wait. No, because it's a cast, so that's fine. So we can use it like that. I really don't know what I've done wrong, so we'll just wrap that one more time, and then we'll kind of look at what the error is, and then we'll kind of go from there. Uint is a syntax error. Are we not allowed to... Let's space this out. I don't think that's a problem, but let's space this out for a second. So we're shifting over by uint 32. Oh, you know what? We can shift unsigned integers. We're shifting an unsigned integer, but the shift value with this operator, I believe, is just a normal integer, which seems kind of weird because you wouldn't want to ever shift to the right by a negative number, or maybe that makes sense, but it doesn't make sense to me. But let's take a look at that and see if that kind of fixes our problem. Uint is still a syntax error, so I don't know what that's about. So what we're going to do is we're going to try to rewrite the code. We're just going to rewrite one section of that code without using any defines, right? So w equals, so actually no, int w equals this U32 value shifted over 4. Oh, I already see that it needs a cast back to... No, it's already uint. And then we're going to mask it with a uint 3. Right, that's what... Oh, shit. Okay, yeah, I see what we... I'm being stupid. It's because we need a semicolon at the end of those lines. Okay, yep, and that was what we needed. So the buffer, the common code is good. Let's go to the image code. So we're going to take the image code, we're going to go up to the image tab, and we're just going to hit that, and we're going to paste that in there and see what we screwed up here. So I don't know what's with shadertoy doing this lately, but you got to go back and forth for it to show up. Okay, so blah, 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 wrong operand types. Okay, wrong operand types. Let's just keep it at that, and I don't... These messages, more verbose than you need them. Let's just actually look at where it's going wrong. So over here, it's going wrong. And why could that be? Well, first of all, a fragment chord. That's a IVEC. So first thing is, we need to take the x and y of this. I mean, that's a biggie. So let's just ignore everything else they said and just try to take that one change and run that and see if we get anything. And we might, hopefully we have a different problem. Floats, floats, and floats. Oh, Gaia. So resolution is a iResolution is a float value. It's not a float value, it's an integer value. So we're gonna take we're gonna take this and we need to just cast it, right? Yeah, we just need to cast. So we're just going to, I don't know, we're going to take a vec2, and we're going to take vec2 res, yeah, iResolution F equals V2, and then iResolution, and then we'll just use these, yeah. Dot, can we do XY? Can we just throw it in there like that? I think we might be able to. Let's give that a shot and see if we can kind of shorthand throw that in there. And then we can just do iResolution. And you know what? That's, you know what? Just float res. We're just going to call it float res. Yeah, fine. Let's just take it like that and see if that works. Did I... Looks like that worked, but floatres.x, like all of those should be the proper, all of these should be the proper types, right? This is a float, this is a float, right? Because the vector values are floats. This should be a float. when we truncate it, trunc uses a float, and then we convert it to integer 32. So that is... What the hell, man? So let's make sure the error is happening at the code we think it's happening at, right? So let's comment out a whole bunch of stuff. Let's paste it in there. I'm kind of frustrated that I seem to just not know what the hell I'm doing. Yeah, that works fine. And then if we take this and we comment that out, or comment it back in, we get a mistake. And I don't get it unless our type def is wrong. So the v2, right? So v2 is a vec2, and vecs carry floats. Okay, fc.x. Oh yeah, duh. Okay, it's the fc.x. Yeah, because that's a ivec, right? Yeah. Okay, yeah, got it. Okay, so yeah, I'm just being stupid. So float 32. I'll just call that fres because I don't want to worry about the room. We'll call it fres. And then let's put everything else back. So take that, and let's try that out and see what happens. IV3 undeclared identifier, so that's an IVEC3, and it looks like I probably have it in some of my other code in the other pages, but let's do IV3, and that's an IVEC3, right? IV3, IVEC3. And then at the bottom, where we're undefining everything, we'll add another slot, and we'll paste that all there. Okay. Okay, let's give that a shot. It said v3d was a syntax error. It might have been because of the other mistakes we made, though. So, okay, so that is actually running. So now we're gonna go and hope that we see something that makes some type of sense. So we got nothing. Let's think about what happened with the tile values, right? We're only using 1 byte, and the canvas was initially the canvas is white, then all the bytes are the same value. And our pixel setting, right? Our pixel setting, was it just putting down blue pixels? Because, I mean, if it's putting down blue pixels, then those blue pixels are also completely full, and therefore that would also map to white based on the way we did it. So if we look at where let's see where the mouse is down. So when we're setting a pixel, yeah, when we're setting a pixel, we just see that we have like so wait, oh, hold on. So we have when we're setting the pixels, it's not, this isn't thinking about where the actual voxels are, right? And so if we set a pixel on that canvas, it's possible that we set it outside of the of the data area. It's also possible that we set the wrong byte for the current layer we're looking at. So let's actually set white so we can more likely set it in a region that will do something. And also, we want to make sure that it's everything is initialized as black. So, initialize data. So, this is not initializing the data, and otherwise, so this was our special pixel for, where are you defined? The state pixel X, state pixel Y. And otherwise, we're putting it all to white, which means that all the tiles exist. So that is not a good thing. Let's just, if it's anything but that state pixel, we want to blank out all of those channels. And even the alpha channel, right? Because we are going to use RGB and A. Erase all tiles. Okay, so that's, so erase all tiles. That's what we're doing, right? So yeah, let's take that and put it in the buffer code. Okay, and we're probably going to have to save this and restart it because it initialized everything as white, and we need it not to be that. So we're going to hit the save. We're going to save this, hit that save button, and we're going to like reload this project, right? We're just going to reload it. We're going to go back to it. So I'm going to close. Oh, hold on. Must give it the shader a name. Hold on. Am I... What the hell? Oh, I think maybe... Let's go back to, so this looks like maybe I opened it up and reset it up? What the hell? I don't know what I did, but let's not do that. So let's go to, let's do, tinyurl.com/sdf-019 and demo. And we're gonna, like, paste all this code. I don't know why that... I've been working in the wrong... file, I guess? Let's just, yeah, let's just, what the hell? Why is this taking so long to load? Okay, so we're back to, yeah, like, loads, but then it's like, ha, you have no name. That's interesting. I'm gonna go look at my profile here and see what we have here. So yeah, this guy right here is what we're looking at, unlisted, 019, so let's go click that. And let's go paste everything in there, right? So let's take the common code, copy it, and paste it into common. Let's take the image code. So the image code, let's paste it into the image section. And let's take the buffer code, and let's paste it into the buffer, right? Okay, let's give that a run. Okay, everything is white. And we're going to, it's unlisted, so if we save it, is it going to tell me, okay, whatever. So tinyurl.com/sdf-019, didn't we just open the fucking thing? Yeah, what the fucking hell, man? I don't know what's going on there. Shadertoy seems to be really weird. It seems to have kind of degraded lately. I don't know what's going on with it, but there's just weird problems. Um, maybe it's my browser. I don't know. Storing voxel values in texture. Okay. So we're saving it. Tags, voxel, tile map, texture. I don't know, whatever. Okay, so now if we reload this, cancel. Yeah, that is weird. It's like it's not saving. Let's give it a run. Okay, let's give it a run, and then can we save it? It's almost as if I'm not really logged in. So let's try to log out and log back in, because that seems to be kind of the behavior of what would happen if some aspects of the website may think I'm logged in, while other aspects of the website must think I'm logged out. That's kind of what that looks like, right? But then we go to it, and it's like, so let's do tinyurl.com/sdf-019 demo. And 3D, so it's the same file, it's the same thing. But I'm getting sick of this right now. This is very bothersome. So common and image, let's take the image code, and let's take the buffer A code, right? Okay, let's give that a run. And the image code is telling me something's wrong, and I hope I did not accidentally overwrite it. Image code is still good. Control A, we'll do Control A, Control V. Okay, so we still have some type of mistake. What is the mistake here? Well, no matching overloaded function found. Really? I thought we had that in the common code, did we not? Let's make sure this is actually the common code. Yep. No way. That's not the... Did I nuke my... No, it's just not the... Okay, it's not the correct common code. Control A. Okay, so let's take... So I think we have to, like, hit compile after we paste, maybe? It's kind of what it seems like. Okay, so let's, So we're having some difficulties here. We don't know quite what it is. But one thing is maybe rather than, well, first of all, I'm surprised that even works, but c4d.w equals 1.0 right here, right? And rather than this, we're just going to You know, we're just gonna keep it really simple. If, since we don't even know what's going wrong in the first place, we should just keep it really simple and just say color4d dot x equals 1.0, and just set like a color where x, y, and z, and just set it red, right? Just make sure that one color is set if this byte value is greater than 0, and then otherwise, if it is 0, we'll just set everything to 0, right? And that will debug, because right now we're getting this white screen. We're expecting to be able to change tile values, and we're not really seeing that. So let's put that into common. So Control-A, Control-Copy, paste this into common. Okay, we got a red screen, so we've got some type of feedback. Now, the problem is, when we're doing all of that math, that's not what we expected, was it? So let's go into the image code, and let's define color4d up here. Well, not define, but declare it. So v4 color4d. And then, you know, so we're going to take all this stuff and we're going to put it into a different branch for now because we don't know what's going on there. And else, we'll put the original sampling code, so we'll do a texel fetch, and then we'll take the integer fragment coordinate, and, oh, actually, we need the sampler, don't we? We need, I believe we need iChannel 0, and then we need the coordinate, fragment coord, and then the level of detail is 0, and I believe we can just leave that out. And then we can do C4D equals the texel fetch like that. Let's give that a shot, see if we remember that correctly or not. And we just pasted that into the wrong spot. So let's save this. Okay, so the image and the common are screwed up. So let's take the image and paste that in there. And then let's go over to the common code. Take this actual common code. And texel fetch, no matching overloaded function found. So, looks like I don't remember how I did that. So let's look at the previous, right? The SDF 18 had the buffer. In the image, we did the texel fetch. So how do we do the texel fetch? That doesn't look right. What the fuck? Have I been editing SDF 18 image this whole time? God damn it. I have. Okay, well, I mean, this is what it originally was, so I have been editing the wrong file. So that's not cool. And I guess we're gonna start putting them in their own folders so we're less likely to make that mistake. But that's That is not... God damn it. Yeah, let's just take all this. And let's just swap it. Let's just hackishly kind of like swap it over. And... take that and we'll put that into the SDF 8. Okay. And let's take that image code. Let's see if that image, the old image code, works properly. Okay, yeah, everything is broken. Great. Yeah, so I don't know. I have made a serious blunder here. It looks like we might need the 0 there for the level of detail. And this is just, yeah, so we don't have this IVEC 3 anymore because that was, IVEC, because we were editing the wrong file. Yeah, having all these files is not, it's not conducive to my workflow here. Okay, so let's take that, and let's paste that in there. Okay, so that works correctly. And in our code now, we can say, like, 0 is not greater than 0. Let's just comment all of this out right now. Let's, so somehow we have messed all this up. So it's all white. So that's interesting. So, oh, got ya. So if we... I don't think we initialized it to all white, right? We... I don't think I'm looking at this code correctly. I said erase all tiles, but we have a lot of places where we are doing things here. Yeah, what the hell? That looks about right. That looks about like what I should expect. So in the common code, right? Like, I mean, that looks good. But why the hell does the name keep on going away? So I don't know why the name keeps on disappearing. That's really annoying. I don't know what's going on here. And the shader seems to not save its information. The fuck is this? Oh, is it because the buffers and things have a... Okay, so we're gonna take all this, and I think that when we cut and pasted common, let's take common, Control A, common, Control A, Control V. Okay, image, let's take image again, Control A, Control copy, and then take all that, paste that in there. And now can we save it, right? Because there's no problems now, right? Okay, so I don't know what the problem is. And it's kind of annoying. It almost seems like shadertoy just is not working. That's kind of what it seems like. Yeah, I don't know what's going on. So let's look at this public one. And let's make sure that we have something where it, yeah, shadertoy is just being kind of weird. We might want to go and write our own GLSL, but I'd rather not to. So here we have, what the hell? Okay, now everything's just like, the tab's missing. Everything's blacked out. Like, that looks pretty bad to me. So, you know what we're gonna do? We're gonna try to, I don't know, let's just close our browser. Maybe something went wrong with the browser. Maybe it's not shadertoy. Maybe it's Torch browser being stupid. So let's assume that it's Torch browser. I don't know what's going on, but that's just not, it's not correct at all. So www. I swear to God, www. Let's do, yeah, let's just go. Let's go to the page. Okay, let's go to 18. Okay, 18, there's this white canvas, and we're setting these blue pixels on the white canvas. Okay, fine. Okay, so SDF19. Yeah, when you open it up, it's just like, huh, you don't have a name, screw you, kind of thing going on here. So that's like not, it's almost like we have some type of error because we shot ourselves in the foot maybe by, so let's, okay, here's what we're gonna do. We're gonna take the stuff in common and Control A, Control V. Okay, we took the stuff in common. Okay, now let's take the buffer code again. So take the buffer code, right? Paste that there. Take the image code. Take all that image code. paste it there. Okay, now it's working. Yeah, I don't know what the hell is going on here. Okay, so I don't know. Let's see if we can. Um, cannot resave shadertoy. I don't know what I'm gonna do. So I think what happened was, because I left it in a broken state, I think that when I saved it in a broken state, I think that screwed something up to where I can no longer resave over it again. So we could test out that hypothesis, right? So let's just leave this, and let's try to create a new shader. Yeah, let's just go to new, and we'll keep it unlisted, and save when broken test, right? So when it's unlisted, can we just do that, and we're good? So let's do submit. Okay, so we still have to assign a tag, uh, save when broken test. If you save broken code, it makes it so you can never ever change the broken code again, maybe? Okay, so we'll do that unlisted. We'll hit submit. Okay, so save when broken test. Updating. Updating non-broken. Okay, so we'll update the non-broken one, and we'll just remove a comment or something like that. We'll give it a run. We'll save it. Okay, and then we'll close it, and then we'll go back to www.shadertoy.com. We'll go back there. We'll look at that shader, see if that change persisted. It looks like nothing saved. It looks like it just nothing, right? I don't see anything, right? It's it didn't even take there, unless we have a different page, right? Um, How do I reply to these comments? Um... You mean because the screen could have ended up that way by just using... Yeah, I don't really know how... How does this... I don't even know how, do not know how the comment system works on here. We couldn't submit your comment. Yeah, so something is up with the system here. Yeah, I don't know. I can't seem to... Oh, okay, so let me refresh that, see if that persisted. And that they replied yesterday to that, so... Okay. Man, I'm giving up on... Okay, so this is just being weird lately. So... What am I gonna do? Uh... I think I need to figure out how to integrate this type of code into the C code I've been working on and get away from the shadertoy code so I can just do it in my C code. Because that's not, that's just not working for me, right? That's, I don't know what's going on, but, something is kind of like very unstable right now. And it seems to be the site doing weird things. I don't know if it's the site doing weird things, but that's what it seems to be. Yeah, I don't know. It just seems weird. So let's Uh, yeah, so let's try to pick up the C code we were doing later. Yeah, let's just pick up the C code stuff we were doing, and that was a different project. It's kind of related, but it's like a different. The concept for that is like a two-dimensional tile map that has like multiple layers that nest inside of each other, so it's not three-dimensional, that project. So I don't really want to context switch back and forth between things because I was trying to like get this code working. Whatever. Yeah, let's just use our project code and try to work with that. And this is too frustrating right now to not be able to like get things working, and then I can't really save it, so I can't really see what's going on, and that's just not cool. So, so we'll look at some of my C code later, and then I don't know. Yeah, let's give the shadertoy code stuff a break, I guess, and let's look at SDF19 really quick and see what these diagrams look like. So yeah, I really wanted to put this stuff into a tile map and pack it this way, and get this voxel, get the second iteration of this voxel engine working. But if I can't really edit things, then I assume it'll eventually be fixed later. But right now it's not working, and it's what day is it? So it's Friday. Yeah, I'd say I'm gonna come back to this on a different day. I'm gonna come. Yeah. Just no. This is. Yeah. Let's actually look at our C code really quick. It's been a while since I opened it, but let's open the. Let's go into our repo drive. Let's go into our Git and data and functions. Is that how I did it? Yeah, I'm pretty sure that's how I did it. And then C11 is probably like the main build system. Nope, we split everything up into different things, didn't we? And also, let's put our column limit back. We had a so let's I don't know. Let's put that back to 64. Okay. And let's look at some of our C code and see. Well, that's a weird place to. Okay. Are they really? Okay. And then I think maybe it was in main. Are these different pieces in main? Yeah, those are different pieces in main. Stable is code that I think is stable that might not be. That I just kind of tucked away in a space where I don't want to have to look at it. Data. That's not as much data as I thought. Functions. Okay, so this is the heart of the code, basically. And Is this like a build system now? Yeah, this is basically a build system here. Now that's actually kind of annoying that now that I'm looking at this, I see... So when I open this, I really don't want to have to like open up libchan top to know like which systems I'm compiling to. So let's well, first of all, let's open this in Explorer and let's give this a run really quick. So let's just make sure that sanity check, make sure that this actually compiles. And little color picker. Okay, so there's a little vital to do, and okay, so I don't know what that vital to do is. I don't want to deal with it. So in our so we have a crash on vital to do. If we get rid of that, let's see if when we run it with without crashing on vital to dos, if we kind of, and I know why I did that. That was so that I would know where to pick this up again when I started coding again, right? Right. So we can get some shaders into our C code, into our C project, and just not worry about shadertoy stuff. Right? Because this I took from shadertoy, and I made some of my I tried to make some of my variables work the same as they do in shadertoy. And I may have not got it completely correct. So, oh well, I'll worry about that later. But yeah, so we have like some shaders. We have like these shaders. I think this was probably from shadertoy as well, right? Yeah, it's 9. So we want to work on this. Yeah, I'll work on that, and let's go into, so libchan top. So let's go into, is that like in the library? Yeah, lib/libchan. Okay, yeah, so lib, I mean, I guess that's organized. So libchan top, and then we have like all this stuff, and there's these different orders. Define macro libchan. Okay, so here's like a little summary, and then so these numbers, they're not very meaningful. So this libchan, so this I think would make more sense. Yeah, this gives us a big overview of like how this system works. So in here, I get why I wanted to keep it kind of small, but when I come back to this, I really want to be able to see kind of like the summary of like, here's all these different systems. Right, here's all the different systems in my code, and yeah, these are all the different systems in the code, and that way we know if we do libchan cur to 15, it's the paint 5D code is going to be executed, and then we can work on the shader code for the paint 5D and kind of figure out how that all works. And that makes more sense to me than the way I had it. So, yeah, and so we can have Yeah, because I wanted to create a Paint 5D type program. So I guess we could do that, and I think having just documentation down here might be nice to have, like, where to find everything. Yeah, where to find everything might be nice to have, like, a little section of documentation in this code. I guess, like, here we have kind of documentation. Yeah, so about this project stuff does not... I don't think it belongs in... It needs to be the main stuff. So actually, this about this project stuff, I think that actually belongs in... I think about this project, it belongs in down here. And then, other... So I like the way we've been doing documentation, having like a documentation section, where we have like a big commented out block, and we just kind of like throw documentation into our code. I really liked the way we've been doing that with the shadertoy code, so I think I'm going to take that kind of lesson from there, and we're going to do the same thing over here with... right, so it's just sometimes you don't know what's the most important thing when you're opening up some code and you want to like get back into it. So I haven't looked at this code for like a few weeks, and you know, I wanted like a nice little summary to tell people how the code kind of functions, and right, and then we had this, right, I wanted to keep it really short where there's not much code in this first file, right? But really, we were way too succinct, we were way too terse, where we didn't have the things we wanted to see right away. And I really want to be able to see this list right up here at the very beginning, so that I can tell where these different things are in the chain, and when I set this configuration variable to where I'm compiling up to, I can easily see that. This crash on vital to do, that's good. I like that being right there, that one setting, right? So, you know, burying everything else, like burying stuff in the data and in here, I think that is a decent place. But the library chain, we really don't want to mess with the library chain unless we're like adding a new library to this chain of libraries. So that's good there. But it's just that we wanted to pull out some of the stuff from the library chain into here, so we have a little summary, a working code summary of how everything is stitched together in the exact order that it's stitched together. So I think that is better, and taking the diagram out of the library chain and putting it here, that also makes sense to me. So let's open the containing folder in Explorer, and let's make sure this still builds, since we've kind of like cut and pasted some things in different orders. And it looks like we're still good. It looks like this project still, yeah, this still compiles. That's good. So we're going to, so I really want to do the voxel engine stuff, so I can create a renderer for pattern drawings and whatnot. But let's also kind of take a break and go back into this C code project, and hopefully, you know, that'll also help me know how clear some of my code is, because when we get back to the to this SDF19, we're gonna, see all these variables, and we're gonna be like, oh crap, that's a lot of variables, oh no, right? We're gonna see these diagrams, we're gonna be like, oh, those are probably nice diagrams. We're also gonna see that the column limit is wrong, and yeah, I don't think I should ever change the column limit. I just need to take 64 and stick with it. I know why I did that, so I could have so I could later on add on four more spaces of indentation, and then add extra layers of indentation and all that. But I think that was a mistake. I think I need to just stick to one column limit when I am coding, because now that I've changed my column limit to 64, I'm looking at this, I meticulously indented everything, and now it's like, well, now it's just annoying to look at, and now I need to change my column limit again to work with this code. So that was a mistake. I think I shouldn't have done it that way. And then I also would have more room to work with, right? Because I have two more tabs over here, right? Yeah, 2 more levels of indentation I can work with. But it's good to be terse, so I do like that I was kind of trying to be terse when I did that. Let's, do we want to just fix this now? Let's close it. I don't know what I changed. So SDF19, we could just fix this now, I guess, because all we gotta do is, expand everything, right? We just gotta take, some of these characters, and, let's just meticulously do some housekeeping, and then, not do this again, right? Just keep 64 as the column limit, and yeah, I chose it to column limit. I stuck with it. That's good. But if we're really not going to use this space, let's just at least pad that out so we know. Let's just acknowledge where those column limits were, right? So let's maybe that's ugly, but I want to always acknowledge the column limit we have by writing divider lines that are exactly to that limit. And so when you open the code, it's obvious, it'll be obvious that it was written with a certain column limit. That's why I do that, meticulously. And copy this, paste this. Right, and we'll just, yeah, let's just, and that was actually off. We'll fix the other stuff later, I think. Yeah, I'm just can't believe I was editing the wrong file when I was doing this earlier today. Editing SDF. So yeah, because now we can take. Now we also have more space to work with as well, don't we? We have a lot more space where, these were kind of we didn't have much space to work with, and that made it a little bit harder to put stuff in here. Okay, that's good for now. I don't really yeah. Open containing folder. Let's do a git bash here. And get status. Yeah, the image code we changed accidentally. So let's look at SDF019 image really quick. Make sure that looks correct. That stuff is pretty trivial, so it's not too big of a deal. Did I actually open up... Man, I keep on opening up the wrong thing. Do I keep on doing that? SDF19 image, right? Yeah. So let's double check the buffer code, make sure the buffer code looks about right. Make sure that we didn't accidentally nuke it while we were frustratedly hacking around. This is still 18. Why do I keep on doing that? So I think it's like I see the 19 and I'm like, oh, but I need the image or the buffer, and I go up instead of down, I think. So that is, I think I'm gonna have to start putting those in their own folder, just because it looks like it's very error prone for me, just because of the way I've named the files. I was about to freak out. It's in common. Common is the stuff. So file open, and yeah, so this stuff, this code. Okay, and do we still have, if we do edit SDF19, do we get like a thing that like opens everything up? No? Now is that because I have not updated my shortcuts yet, or is that just not a thing that exists? Let's just take SDF19 for a second. Really? Have I fucked up that, oh, 019, I see what I did there. Okay, so let's do edit SDF19. So obviously, I didn't memorize that right. So SDF19 edit, and then SDF19, and edit. And we'll take this. We'll add a to-do. Pick up with voxel engine work. So I like the idea, and I think it would be really fun to do, but I don't know, shadertoy is being kind of weird, so we're going to not do that right now. We're gonna and have I been doing everything with the wrong column limit? Yeah, so let's not, so I've been doing it to all my shortcuts with that column limit, so we can almost tell what day we started doing all this shadertoy code, because we see all the wrong indentation, because okay, so yeah, we're going to yeah, let's yeah, that's annoying. That is annoying. Let's just, this will be an opportunity to see how we can get back into the code, and let's, before we save this, now that I remember why I did the crash on vital to do, I'm going to put that back as a 1, and then we're going to open containing folder. And so it makes sense for, you know, the only thing in my in my source code, in the root of this project, the only thing that is actually a C11 file is this AAC 2020, which is the same name as the project. So that's the first place you're going to look when you want to figure out what's going on. And so that was where I first looked, but there wasn't enough information there. It was like, oh, there's these very basic rudimentary things that I want to know right away when I'm going to recompile, and they weren't right there. It required opening other files to get to that information, so we shuffled things around again into a better order to where the things I want to see right away are, at the top, right? So we better prioritized everything. And let's just make sure that this compiles the way I think it's going to compile. So it should be like there should be a crash on a vital to-do. And I see a vital to-do 2020 1114. And so that was almost 1 month ago. So if we take this vital to-do and we go Control H and we look for it, I made sure that when I have some type of error message, it is exactly the AAC 2020 folder. It's exactly verbatim in the source code that way, so that way I can find it. So if we look for this and we go Find All, we can see what this to-do was all about, right? And we can kind of see like where we were lefting out. So GPU data test, CPU and GPU. So we have like some test code, and it looks to me like we have some math. Did we actually do the math for test coordinate conversion, right? So component dex to pixel x, pixel y. Oh, okay, I see. So this was really basic. Okay, got it. So this is GPU data. I was confused for a second because I thought this might have been the paint stuff. And so the paint 5D stuff is a different layer of the source code. And if we do well, actually, it's GPU data paint 5D, right? And then there's functions here, and these functions here should, it looks like we don't have the functions yet. Initialize, so we give the block some name, and this is the function section. Why is so functions, so we need like the more complicated conversion functions for how we're storing the data and how we're like manipulating it. But in the main GPU data here, it's just the most basic access that we can do to get at the data and write to the memory. So yeah, code is hard, man. So many things to like remember in your head, and then eventually you bury yourself in stuff of your own design, like you just don't remember what any of it does. So I definitely like the fact that I got these namespaces, so I know exactly what the namespaces are, and like in an RPG game, where you don't know where you left off. We have a vital to-do that kind of lets us know where we left off with the GPU data. And I know we wanted some way to we're going to just say that Paint 5D is like the first editor, and because it's the first editor, it will be we'll just use the first shader slot for the first editor, right? And that's just how we'll do it. And then we could actually, if we can get that stubbed in and we can get the Paint 5D type code to work, we could then add some more code to add another editor for the voxel type code we're doing, and then we could have those two editors and design them both to use a 512 by 512 section of memory. And I don't know how they're gonna share memory, or if I should have them share memory. I guess maybe I should keep it as simple as possible. I think, yeah, keeping it as simple as possible and just having them use their own block, so like each editor has its own block of memory, and that would probably make things a lot easier. So, yeah, that would make it easier. So, the next time I'm going to start working on, I'm going to go back to the engine work so that I can, back to my C code work, and I'm going to take kind of the stuff that I've been learning from shadertoy and try to apply it into my actual project, because I haven't been doing that, but yeah, there's just a lot of stuff here, and you can kind of get lost, because you definitely need really consistent habits for the way you do things, because there's no way, I mean, some people have photographic memories, so there is a way, but for me, I don't, so I need to have a very consistent habit when I write the code, just because you end up with a lot of code and you don't know what it all does anymore, and then things end up in the wrong place. And so we just want to have as meticulous of an organization as possible, because no matter how hard we try, we're going to forget what some of this stuff does. So we want to try to organize in a way where we can get back into the code easily, right? So that's what we're going to focus on, and just keep the code as simple as possible, because the simpler you keep it, the less things you have to memorize, the easier it's going to be to get back into that code and remember how those different aspects worked. So, yeah, let's, with that, okay, so Vital To Do 2020 1114, I'm going to run it one more time because I've kind of been running around in it. I want to make absolutely sure it still runs. Okay, yeah, so that still works. So let's do git bash here. Git status, git add dot git commit dash am, peeking at code after 1 month, to do Paint 5D program. Okay, git push github master. So with that, let's say that tomorrow on our to-do list, to do AACU 2020, get Paint 5D working. So Josh, something to work with, right? So we want to get that Paint 5D program working now. With my shader code and whatnot, it's not as nice as shadertoy, and that's kind of why I was doing stuff in shadertoy. The syntax of my shader code seems a little bit different, so maybe I should research about why is my shader code different? What is the syntax? Can I get my shader code to kind of directly match what's in shadertoy, so I don't have to do little transcriptions? Because right now I have to do some transcriptions, and it might just be the version of GLSL I'm using. And actually, we could look that up. So, what version of GLSL does shadertoy use? Right? Like, what does it use? So, image shaders. Image shaders implement the main image function in order to generate the procedural images by computing a color for each pixel. This function is expected to be called once per pixel and is responsibility of the host application to provide the right inputs and to get the outputs from the color from it and assign it to the screen pixel. The prototype is okay. And let's take a look at some of my shader code really quick and see what the difference is. So if we go into our project and we see frag bed default shaders, so that's nice that they're kind of right there in a folder. And if we look at one of them, we can see, oh, these are the default shaders, so that's why they're inside of a string like this. But, so that was also kind of annoying. Originally, I had to do it like this. But we see version 330 core. You know, we don't have... I don't think there's any main here. There's no, like, main function, right? It's just, like... Or, wait, no, there's main right there. So where's that void main? And... Oh, got ya. So, main image. Is main image just a shadertoy thing, or is that or is that a specific GLSL kind of thing? And I don't know if it is. So what we could do is we could try to go into yeah, so let's go put this over here for a second. So the documentation, so if we take that signature and just try to Google it, shadertoy, so that kind of looks like it's just a shadertoy thing. Let's try void main image. How to shadertoy GLSL sandbox void main image. So I think that is a shadertoy specific rigging for shader code. You know, we could probably easily fix up some of that with like a with maybe some defines, right? And just kind of like hack that in there. But let's see, version 330. So what is version 330, right? First of all, am I using an old version of OpenGL? Should I be using something newer? Version 330... 2019. What version of GLSL are we on? I don't know. So I'm using, so I am using 330, and that was March 2010. So I would say that, I'd say that's a little bit out of date. Now, maybe we should move forward with some of the newer stuff. So let's just see what 460, June 2018. So, list of OpenGL shading language versions. GLSL versions. OpenGL version. It's not really OpenGL version, it's... I don't really care about these, just in case, did you really want GLSL versions? Just in case, let's make a note for that. And we'll take that GLSL versions. So it's important that I have like a lot of different things that I can do, so that when things go to hell, I can move to a different task. So, okay. And GLSL version 330 tag. 330 tag. So the question is, so there's like a 460 now. Uh, 460 core tutorial. So let's see if we can find a how to convert GLSL version 330 core to GLSL version 100. That's not what I want. Main differences between OpenGL versions. So let's see if we can find anything. Actually, no, that's not what we want. We want the difference between the GLSL versions. GLSL versions, differences at a glance. That is what I would like. 2012, so that's generally GLSL 330 is on par with. Oh, okay, so we can check the changes section. So let's see, GLSL 330 spec. Okay, let's take that and just put it in here. GLSL 330 spec. 330 spec. Okay, and so there's a changes section in here, huh? Let's see if we can do changes. Changes from version 1.5. Note, no features removed or deprecated between version 1.5 and 330. Okay, cool. So let's try to, so we wanted like a GLSL spec 460. So it looks like the current spec is 460. So let's see what is different. And $460. Okay, so let's look at so there's a changes section, a lot of stuff, changes. So there's some Vulkan stuff. Yeah, so they're trying to make stuff Vulkan compatible. So let's just take this and let's put this into GLSL 460 spec and 460 spec. Paste that, and then let's look for. Let's see if we can find GLSL 460 tutorial. Right? Let's see what the this still says 330 core. So let's do version 460 core fragment shader, right? I just want to know what 460 looks like. Can we just look for main? Can we find main? It's not like we're doing super advanced stuff where we need like the latest, greatest OpenGL. Okay, yeah, so let's just stick with the version we have. Unless there's actually a reason, like, oh, it has a certain new feature that we absolutely need, like, for instance, integer textures, absolutely need those. So I would, that would be something where I would be like, yep, we actually need to switch, but yeah. Okay, I'm done streaming for now. I'm tired and disappointed with the shadertoy stuff, so yeah, later.